Welcome to the pale blue dot of the solar system, Earth. The planet Earth is teeming with many types of complex organisms. These organisms are found in equally complex biomes, which each have their own distinct climate, flora, and fauna. Each biome is so different in which types of life they support, they are each like their own little planet on a much larger planet. We will begin our tour of the planet by exploring the oceans. Our tour of Earth's many biomes begins with a look at the oceans. Oceans themselves take up more than 70% of the Earth's surface, and most of the oceans, particularly the depths, have not been fully explored. This makes it the largest biome on planet Earth. The constant motion of the oceans results in currents and waves that may either be warm or cold depending on the weather in that area. Temperatures in the oceans range from just about freezing at the poles to tropical clear waters that are as warm as a bathtub. The average temperature of all oceans, though, is about 39 degrees Fahrenheit or 4 degrees Celsius. Oceanic plant life is among some of the most diverse sources of plant life on all over Earth. Over 1 million plant species have been identified in the oceans, and scientists estimate that there are 9 million that have not been discovered yet. Some examples include seaweed, algae, kelp, and seagrass. Some ocean plants have adapted to the low light levels of the Earth by growing very tall and close to the surface to soak up what little sunlight they can. The life forms found in the ocean vary greatly depending on which area of the ocean one is exploring. However, in general, the ocean is inhabited by saltwater fish, plankton, crustaceans, whales, dolphins, and porpoises. There are many different types of adaptations that these animals use to live in the ocean. For example, some fish form schools to make food gathering more easier and to increase their numbers to increase survival chance. Others have evolved a hydrodynamic form that makes swimming through the water much easier and easier to escape from dangerous situations. Humans impact the biodiversity of the ocean by causing the temperature of the oceans to change through anthropogenic sources of greenhouse gases and other climate-changing substances. Humans will also occasionally spill oils from pipelines that run through the ocean, and that can cause a lot of harm to life that lives in the ocean. Shown here is a food web of a typical ocean ecosystem. And shown here is a typical food energy transfer pyramid of a typical ocean ecosystem. The next biome we're visiting is the coral reefs. While coral reefs are found in the ocean, the inhabitants of these reefs are so diverse, they make up their own ecosystem and biome. Several scientists even call coral reefs the rainforests of the ocean due to their complexity and biodiversity. Coral reefs cannot stand temperatures much lower or higher than 29 to 25 degrees Celsius. The development of these structures is aided by algae that are symbiotic with reef-building corals, known as zooxanthellae. Coralline algae, sponges, and other organisms, combined with a number of cementation processes, also contribute to reef growth. Because of the complexities, thousands of species of fish and invertebrates live in association with these reefs, including but certainly not limited to clownfish, lionfish, French angelfish, filament-tip prawn goby, and snails. All of these organisms have adapted to live in tandem with one another. In other words, the species that live within coral reefs form a symbiotic relationship with the coral real estate, if you will. While coral reefs are very beautiful and complex, they are also very sensitive. They respond negatively to temperature change, pH change, water nutrient content, and even light level. These factors cause the beneficial algae that act as the primary producers to die, and the corals are left completely white. This phenomenon is known as coral bleaching. A few anthropogenic activities that are harmful to corals include coastal development, overfishing, oil discharge, dumping of garbage, as well as sedimentation and pollution from agricultural runoff. Shown here is a typical energy transfer pyramid that shows organisms contained in coral reefs. And this picture shows a food web of typical coral reef animals, although they are certainly not limited to these animals and plants. Now, if we journey deeper into the ocean, we find the benthic biome, which lies miles below what we think of as the ocean. In this biome, it is very dark and very cold and very high in hydrostatic pressure. The average depth of the abyssal plain is 11,000 feet or 2 miles. The abyssal plains comprise some 60% of the Earth's surface. The abyss is mostly flat but is peppered by seamounts, islands, and deep rifts. Because light does not penetrate deep ocean water, the energy source for deep benthic ecosystems is often from organic matter from higher up in the water column which drifts down to the depths. This low light level also contributes to the low plant levels in the deep ocean. However, many types of algae and seagrasses can still be found in that low in the ocean. Dead and decaying matter sustains the benthic food chain. Most organisms in the benthic zone are scavengers or detritivores. These organisms can include whelks, starfish, and sea bats. Just as in the oceans, oil spills and other anthropogenic causes of ocean temperature change can cause harm to benthic ocean life, as any pollutants that enter the ocean, even on the upper levels, will eventually trickle down into the benthic zones. Here is a typical food web regarding life in the benthic zones. And here is a simplistic energy pyramid for benthic zone animals and plants. The next biome we're visiting are the temperate deciduous forests, which are found in Europe, the eastern United States, Canada, East Asia, East Australia, and South America. These forests have an average temperature of a cool 50 degrees Fahrenheit, and they get about 30 to 80 inches of rain per year. Climate varies by season because they get all 4 seasons. Plants in these areas include lichen, moss, ferns, wildflowers, and trees, of which include oak, birch, and magnolia trees. The plants in these forests have adapted to their environment, an example of which is how they have long branches with lots of leaves to soak up as much sunlight as possible. Animals that live there include white-tailed deer, raccoons, brown bears, red foxes, and porcupines. Animals in the forest have adapted to the ever-changing climate by hibernating or migrating. Many animals have also adapted to have sharp claws and strong teeth to crack various nuts and other food sources with. Small mammals in these forests have strong padded hands to help them climb trees and a tail to help them keep balance. Temperate forests are being cut down, as many other types of forests are, which is harmful to the plants and animals there. And shown here is a typical energy transfer pyramid. Shown here is a food web for a typical deciduous forest ecosystem. The next biome we're visiting are the tropical forests, rainforests to be exact. These are found near the equator, such as in South America, Central Africa, and Southeast Asia. They get about 8 feet of rain per year. Better bring your umbrella. The average temperature of these rainforests is about 77 degrees Fahrenheit, but can be a lot warmer. Plants include bromeliads, mycorrhizals, Venus flytraps, Brazil nut trees, and sandbox trees. Many types have a very thin bark, which prevents parasites from being able to attach as easily. Mycorrhizals have a type of flower that has a thick, waxy leaf that allows them to catch more water, which animals use to drink. Animals for this area include the African forest elephant, chimpanzee, Bengal tiger, king cobra, and vampire bat. Animals such as various species of monkeys and rodents have adapted to climb trees for food and shelter, with their sharp claws and long tails and arms. Many animals, such as frogs and snakes in the area, have adapted to blend in with their environment as a method of defense. Tropical rainforests are a biome that is one of the most affected by humans. Rainforests are being cut down rapidly, which is obviously harmful to the biodiversity of the rainforest. Here is a typical food web for an Amazon rainforest. Here is a typical energy pyramid for an Amazon rainforest. And the Amazon rainforests are so diverse, they are absolutely not limited to these organisms. The next biome we will talk about are the grasslands. Grasslands are found all over the globe, but mostly in the western United States and parts of Central Asia, but they can also be found in southern Africa and South America. The temperatures range from 20 degrees Fahrenheit in the winter to 70 degrees Fahrenheit in the summer. They get an average about of 10 to 30 inches of rain per year. The plants located in grasslands do not vary all that much. They include mostly different kinds of grasses, including big blue stem grass, blue grama grass, Indian grass, and June grass. There are also some flowers there, including the purple coneflower and the fleabane. The seeds of many grassland plants have silky tufts of hair, which allow them to be blown in the wind like little parachutes so they can pollinate. Animals that live in the grasslands include prairie dogs, bobcats, badgers, bald eagles, and coyotes. Many animals are small and blend in with the ground and the grass to be seen less easily by predators. Grasslands are greatly affected by humans in 2 major ways: farming and urban development. Grasslands are being used by humans, which is driving the animals away. When grasslands are converted into cropland, it reduces the food source for many wild animals. The development of land drives animals away from populated areas and changes the conditions of the environment. Both farming and urbanization can result in pollution of the air and water of the grasslands and can harm the soil as well. Here's a food web for a typical grassland ecosystem. And here's a typical energy pyramid for a grassland. The next biome we will explore is the taiga, which comes from the Russian word for forest. Taigas are found in North America and northern Eurasia. They have a wide array of temperatures, from a nice 70 degrees Fahrenheit in the summer to as low as negative 65 degrees in winter. Plants include the black spruce tree, the Siberian spruce tree, the white fir, and the paper birch, all of which are trees. Many trees in the taiga are coniferous, which means they have needles that stay around all year round rather than leaves that die or fall off during a certain time of the year. This is good for the trees because this means they can photosynthesize all year long. This is a helpful adaptation because in the taiga it is cold all year long with little sunlight, and there isn't a warmer season with lots of sunlight like there is in a deciduous forest. So these needles allow for the trees to make as much nutrients as possible with the little sunlight they do have. Animals that live in the taiga include grizzly bears, bald eagles, bobcats, Canadian lynx, and river otters. The mammals have thick fur to withstand cold temperatures, and some mammals, such as bears, have adapted to hibernate through these cold winters. Here is a simplistic food web regarding organisms in a taiga. And here is your typical energy pyramid regarding animals in a taiga. Temperate rainforests can be found scattered throughout the earth. Mostly they are found in Eastern Asia, but they can also be found in Western North America, Europe, and South America. They are much cooler than tropical rainforests, with the temperature usually ranging from 60 to 80 degrees Fahrenheit. They get about 5 to 16 feet of rain a year. Plants of a temperate rainforest can include the Douglas firs, the Indian paintbrush, the red cedar, the Sitka spruce, and the Pacific rhododendron. The trees have a very thick bark for protection. Animals that live in temperate rainforests include mountain lions, elks, tree frogs, porcupines, and the rubber boa. Here is a food web depicting the predation and prey relationships between organisms in a temperate rainforest. And here is a rather fleshed out energy pyramid regarding life in temperate rainforests. The next biome we're visiting are tropical seasonal forests, which are found in South America, Central Africa, and Indonesia. They have an average temperature of about 81 degrees Fahrenheit and are very humid throughout most of the year. Plants of a tropical seasonal rainforest include orchids, strangler figs, ferns, bristlecone pines, and acacia trees. The trees have thick bark for protection and deep roots so they have access to more groundwater. Animals of the tropical seasonal forest include the white rhinoceros, giraffe, howler monkeys, tortoises, and tigers. Many animals, such as the zebra and tigers, have adapted to blend in with their environment so they can hunt with more stealth or hide from predators more easily. Animals have also adapted to migrate. One large impact on this biome is poaching, done by humans. Many large animals, such as rhinos and tigers, live in this area and are hunted for profitable items such as for their tusks or pelts. The mass amount of hunting has led to near extinction of some species that are very important to the ecosystem. And this poaching could ultimately lead to a loss in biodiversity in tropical seasonal forests. Here's a rather simplistic look at a basic food chain in a tropical rainforest. And here is an energy pyramid dictating the energy flow in a tropical seasonal forest. The next biome we're visiting is the chaparral biome. The chaparral biome is found scarcely on Earth, mostly in the western United States, but also in the Mediterranean and parts of Australia. The chaparral has a very dry climate, especially in the summer months. However, precipitation levels can increase some in the winter months. There is a very wide temperature range, ranging from 30 degrees Fahrenheit in the winter to as high as 100 degrees Fahrenheit in the summer. The average annual temperature is 59 degrees Fahrenheit. The chaparral only gets about 10 to 17 inches of rain all year, and most of it comes in the winter. Plants in the chaparral can include the blue oak tree, the coyote brush, common sagebrush, the king sugar bush, and the birch leaf mountain mahogany tree. Plants in the chaparral have hairy leaves so they can collect as much moisture as possible in the very dry climate. Some animals in the chaparral include the black-tailed jackrabbit, the golden jackal, the gray fox, puma, and the wild goat. Many of the mammals that live in this biome, such as the foxes and pumas, have thickly padded furry pads on their paws, which help them travel the rocky terrain and the heated ground. The chaparral is an area that is affected by pollution in the southwestern United States. The surrounding waters and the air are both polluted from anthropogenic activities. Here is a food web depicting predation and prey relationships in a chaparral ecosystem. And here's an energy pyramid depicting the energy flow in the chaparral biome. We're getting close to the end of our journey. This biome is called the desert biome, and it is the driest of all biomes. The temperature in hot deserts ranges from about 60 degrees Fahrenheit to as high as 120 degrees Fahrenheit, although the average temperature is about 100 degrees Fahrenheit. Cold deserts do exist too, and can range from about 30 degrees Fahrenheit to about 75 degrees Fahrenheit. Deserts get only about 7 inches of rain a year. Due to the very dry climate, plants don't survive very well in the desert. However, some examples of plants in the desert include the barrel cactus, the saguaro cactus, the Joshua tree, the chain fruit chala, and the desert ironwood. These plants survive in the desert because they perform a very specific form of photosynthesis in which their stoma remains closed during the day and opens up at night so they can photosynthesize while the sun isn't out. Some examples of desert animals include the whip-tailed lizard, the tortoise, some species of vultures, and the desert coyote. These animals survive in the desert by surviving on only little bits of water and enough food to sustain them through the harsh climate. This is a food web depicting some of the animals that live in the desert biome. And here's an energy pyramid depicting the energy transfer of organisms that live in the desert biome. And here we are at the savannas. Savannas are mostly located in Africa, but can also be found in South America or Australia. The average temperature in the biome is about 80 degrees Fahrenheit. The savanna gets about 30 inches of rain per year. Plants that live in this biome include the acacia tree, mutagrass, jackleberry tree, elephant grass, and the manketti tree. These plants have adapted to conserve water. They have long taproots that can reach the deep water table, they have thick barks to resist fires, trunks that can store water, and leaves that drop off during the winter to help conserve water. The grasses have adaptations that discourage animals from grazing on them by being sharp or bitter. Animals that live in this biome include the African elephant, zebra, lion, Nile crocodile, and mongoose. Animals in the savanna have adapted to have long and strong legs so they can migrate often and for long distances, also for escaping predators. Many animals have large patches of thin skin to lose body heat faster, such as the elephant. Poaching is a huge problem in this biome. Rare species, such as the elephant and zebras, are being hunted for their pelts or for their horns, and this harms biodiversity. Here is a food web depicting the relationship of various savanna organisms. And here we are at the tundra. Tundras are found in northern Canada and Siberia, as well as Greenland and Antarctica. The tundra is a very cold biome with an average temperature of negative 15 degrees Fahrenheit, but the temperature can drop to as low as negative 90 degrees Fahrenheit. There are not a whole lot of plants in the tundras. However, some species include the Arctic moss, Arctic willow, bearberry, caribou moss, and the pasquet flower. These plants have adapted to endure the harsh winters by having sturdy roots and have the ability to live without much water. Animals in the tundra include the Arctic fox, caribou, grizzly bear, musk ox, and the snowy owl. The animals, especially mammals, have adapted to have lots of thick fur and layers of thick fur to withstand the cold winters. The tundra is greatly affected by the pollution on Earth caused by humans. Pollution from mining and drilling for oil has polluted the air, lakes, and rivers of the tundra. The tundra has a lot of carbon dioxide in the atmosphere above it, causing the biome to literally melt. Because the carbon dioxide is a greenhouse gas, trapping heat in the atmosphere. The melting of the ice is harmful to the natural habitat of these animals, as they are used to living in a very, very specific environment. Here are the organisms and how they interact within a tundra biome. And our final stop on this journey are the freshwater wetlands. These are located on every continent on Earth. They can vary greatly in temperature, from below zero to above 100 degrees Fahrenheit.
Some plants that live in this biome are pond lilies, cattails, tamaracks, mosses, and blue spruce trees. Some of these plants and vines, in particular, have adapted to the freshwater wetland environment by growing very rapidly so they can draw water from a bunch of different places at once. Animals of the freshwater wetlands include cranes, alligators, snapping turtles, beavers, and geese. Wetlands are disappearing rapidly for a few different reasons. They're often cleared out so they can be used for human, commercial, or agricultural uses. Wetlands are increasingly being polluted because of industrial and agricultural runoff, introducing harmful elements to the biome. Climate change is also causing the ice caps to melt, and this can result in the wetlands being flooded. Invasive species are also a problem in the wetlands because they pose a threat to the plants and animals already living there. Here's an illustrated example of a food web that would take place in the freshwater wetlands. We hope you enjoyed our journey through the biomes of Earth. To the left is me, your tour guide and co-researcher of Earth's biomes, and to the right is our head researcher Hunter Grove. Please come visit us again.